Alright, so this is going to be a worksheet for distance and displacement. So question 1 here, you got a picture. It's a diagram of this little guy Chris, and he's walking around Sayre Park. Alright, so part A. If Chris walks to point C, what is his distance? So this question here is asking for distance, not displacement. So there will be no direction. So from A to B is 8 meters, and then from B to C is 6 meters. So 8 plus 6 equals 14. And then 14 meters, which is no direction. Alright, so for part B, if Chris, he walks to point B, what is Chris's displacement? So with displacement, we all know that you need a direction. So from A to B, he goes down or south 8 meters. So here, that's all it is, just 8 meters down or south. And then part C to this problem, if Chris walks from point A and walks all the way back to point A, what is his distance? And then I want you to solve for his displacement. So with the distance, you have to add up all the parts all the way around. So starting with A to B, which is 8 right here, and then B to C is 6, so 8 plus 6 is 14. And then from C to D, 3, and then from D to A, back to A, is 10. So when you add all these up together, it equals 27 meters, right here. Distance, no direction. So displacement, this one, it's easier than you think. You don't have to do any work to it. Starts at A, and then he ends at A. So his overall displacement, he's not going anywhere. So that's just going to be 0 meters. Alright, so number 2 here. Mr. Miranda is running the marathon. He starts at the start point and finishes at the same spot. What is the final displacement? This is very similar to the last problem where he starts at the same spot that he ends. So the answer to this is, again, 0 meters. And there's no direction here because he doesn't go anywhere. Alright, so number 3, this is just a little box with the equations. X equals x naught plus v naught times t plus 1/2 at squared. V squared equals v naught squared plus 2a delta x. And then you got delta v times delta t equals delta x. And that equation comes from v equals distance over time. Alright, so the first question here is asking, if you start at 0 meters and are at rest, accelerate at 2 meters per second squared, where would you be after 5 seconds? So you take what you know that x initial equals 0, your acceleration equals 2 meters per second squared, you start at rest, so v naught equals 0, and time, I want you to know for 5 seconds. So by looking at the equations, you know you have all the information for this equation here, so you can write it down. And simply just plug in what you know. 0 for x naught, 0 for v naught, times 5 for t, plus 1/2, 2 for a, and then again 5 for t, and then you square that. So 0, 0, and then 1/2 of 2 is 1, times the square, times 5 squared, which is 25. 1 times 25 is simply 25. And that is your distance in meters. Alright, on to part B. And the last problem on this worksheet. If your final velocity is 2 meters per second, and you start from rest, your acceleration is 2, your time is 1, what is your x equal to? So by this, you could follow the rules of the second equation. So you write it down, you have v squared equals v initial squared plus 2 times acceleration times delta x. Alright, so you have a equals to 2, and you solve for x, plus you start at rest, so that's going to be 0 squared, and your final velocity is 2 squared. So 2 squared equals 4, 0 squared equals 0, plus 2 times 2, which is 4x. So 4 equals 4x. And then simply just divide by 4 on each side, and 1 equals x. Your distance is 1 meter. And that is the end of this worksheet.